Looks like pretty much a theory question. Yeah, they're basically the same question, which would have been pretty much covered. Oh no, the first one is easier again. It's more like an exercise for the first, for lab 7. So you got a square plate, you got a left temperature 10, you can see that below, a right temperature 20, you can see that below, bottom temperature 120, top temperature 0. The steady state temperature, so what it doesn't really say and it should, is that this plate is insulated on the top and the bottom. Steady state temperature is given the solution of this, mesh it into squares. So there are 4 internal nodes, so that's, you have to mesh it 3 to 3 like start lab 7. Use finite differences or the mean value property to write down an equation for each node. To use finite differences is basically just not the way to do it. Using finite differences essentially is question 2, and we'll get to that. It's much easier to just use the mean value property. The mean value property says that if you take any temperature, say temperature 1 there, that if you were to draw a circle around temperature 1, this is supposed to be a circle, that temperature 1 is the average of the temperatures on that circle. And what you can do, rather than using the infinitely many points, just use the grid points. T4 above, T2 to the right, 120 below, and 10 to the left. And do that for the 4 temperatures. And that's what we have on the right. And that's basically what you'll be doing in lab 7. That's that. The second question then, the theory question, is use finite differences. So if you did the above question with finite differences, what would that look like? So on a thin plate, you also need it to be, you want to choose, so the discrete mean value property means basically that rather than averaging on a circle, you average on just 4 internal points on a mesh, on a grid. So you choose delta x and delta y to be equal. So it implies that the plate is chopped down to squares like the above. And then each of the internal points, look at them, T1, T2, T3, T4, they all have 4 adjacent temperatures. So that's what this is kind of saying, that every point, so the red point in the middle, has 4 adjacent temperatures. And if you have it set up on an axis, and that axis is implied by this, we are approximating a sum of 2 second derivatives at this point here. Now, to approximate a second derivative, you use this formula that'll be given to you at the back of your exam paper. And basically what it says is, so at a point xi, so that's like your current point, you look at the y value at the next point, so that's the next point over, minus twice the current point. Remember, this is the current point. So y at the current point is the current value of y, and then x sub I minus 1 means the previous point. Now what that's kind of referring to, of course, I could say, is something like this. So like, here's your current point xi, what do you call your next point? Xi plus 1. What do you call your previous point? Xi minus 1. So that's what that's talking about. But here we have next in terms of x, but also next in terms, next and previous in terms of x, and also next and previous in terms of y. So that's what we've kind of drawn up above. You have T2 is the next y in the y direction. T4 below is the previous y in the y direction. Then T1 is the next y, or well, the role of y is being played by big T here. So that's T1 is the next with respect to x, and T3 is the previous with respect to x. So we basically use that formula twice. So the second derivative here, we're talking about this axis here. So the next is T1 minus twice previous, or excuse me, twice current, and the current we're just calling T, plus previous, T3, divided by delta x squared. And then we're looking at the second derivative with respect to y. We're looking at the y direction. We're looking at these. And so the next is T2, and the previous T4, and the current is the same. And we divide by delta y squared, but we assume that delta x equals delta y. And so if you multiply by delta x squared, it will, and you're multiplying a sum, both of them are going to be multiplied by delta x squared. And because delta x is equal to delta y, multiplying by delta x squared also gets rid of the delta y squared. So you're left with this, and then it's just simple algebra. Add 4t to both sides, divide both sides by 4, and this is what you wanted to show. That temperature in the middle is the average of the 4 adjacents.